Now on to example 10.6, and what we have here is two different products that we're going to sell. Yeah. Now when we sell two different products, the demand for the two products could be correlated. Okay, sometimes if they are complementary products, then if the demand for one product goes up, then the demand for the other product also may go up. But on the other hand, if they are replacement products, so that means if the demand for one product goes up, the demand for the other product may go down. Or if these two are completely independent, then the demand for each other is going to be not affected by each other. So when we have such a situation, which is quite common, then we have to set up a correlation matrix between the products. So here the correlation, of course, along the diagonal would be 1, because it is a product, it would be correlated with itself perfectly, of course. Now the correlation between product 1 and 2, okay, so here is where we can try different possible values. So what if the correlation, so here we're going to try only 3, but you can try any number of possible values for correlation. So this is our risk sim table function. So we use risk sim table and we use these 3 cells. Okay, so starting from minus 0.9, 0 and 0.9. Now the correlation across on the other side of this symmetric matrix is going to be the same as this. So the correlation between product 1 and 2 would be the same as product 2 and 1. So this is just simply equal to that. So now we have 3 different simulations that we're going to run. So we have simulation 1, 2 and 1, 2 and 3, and the correlations of these 3 simulations are those. So here the demand are correlated in the opposite fashion. Here it is completely independent, and here the correlations are in the same direction. If one demand goes up, the other demand also will go up. Okay, now we're going to assume, for the purpose of this modeling, the demand distribution itself, the distribution of demand, is going to be the same. Of course, it's going to be adjusted by this correlation matrix. We will come to that in just a second. But the basic probability distribution for demand for both the products, we're going to assume they are the same, and these are the initial values for our order quantity. Let's assume that we're going to order 200 of the first calendar, 200 of the second calendar. So let's give names here. So order quantity 1 and order quantity 2. Okay. So now we're going to do demand for product 1. So demand for product 1. So let's start with round. And this is risk triangular. Okay. And the 3 parameter values. Okay. So now we have to tag along with these 3 parameter values before we close the parenthesis. Risk correlation matrix. And highlight the correlation matrix that we have there. And then we have to provide the product number. So this is for the first product, so comma 1. So now we 1 parenthesis for risk format, then 1 for risk triangle. And then for the round, you have to specify how many decimal places we want to round. So that's, and we repeat the same here, round, risk triangle, Okay, since this is the same parameters for this triangle, we use the same 3 cell references, and then risk core mat that. Now this time this is for product 2, so do product 2, 1, 2, and then 0 for rounding and finish. So now the demands would be adjusted for the fact that product 1's demand and product 2's demand would be correlated according to this value that we specify here. The first time around will be minus 0.9, second time around will be 0, which means they are not correlated at all. Third time around it will be 0.9. Now the model itself is exactly same like in the previous cases, except here we have 2 different demands and 2 different order quantities, product 1 and product 2. So sales will be the minimum of that and that, and here it will be minimum of the second order quantity, the second demand. Return is first order quantity minus sales for the first product, and same for the second product. Revenue is sales for the first product times unit price. Okay, same here, sales times the unit price. Here we are assuming that the price for the 2 products will be exactly the same. So cost, order quantity times cost. Similarly for the second product, order quantity times cost. Refund, okay, return times the refund price, okay, return times refund price. Profit is revenue minus cost plus refund. Same here, revenue minus cost plus refund. Now the total profit is the sum of these 2 profits, and that is our output cell. So let's give a name and color code this and identify this as our output cell in at risk. Okay, go to at risk, add output, okay, and it is pointing to that cell, so that click OK, and that's our output cell. Okay, now we have to set up the summary outputs. Okay, so we have risk min of total profit, comma, the simulation run. The first time the correlation will be minus 0.9, remember. Second time 0, third time plus 0.9. Risk max total profit, comma, simulation run. Risk mean total profit, comma, simulation run, and then risk standard deviation total profit, and then 5th percentile risk percentile total profit of 0.05, the simulation run. The 95th percentile is risk percentile total profit 95%, 0.95, and simulation run. Okay, so now we copy. Alright, so now we are ready to run the simulation itself. So 1000 replications, and there are 3 simulation runs, simulation run 1, 2, and 3. So now we start simulation. Okay. All right, so now we have all the three simulations done. Okay, the first simulation, when the two products have opposite kind of correlation in demand, this is what the profit distribution for 1000 replications is going to look like. It's, kind of evenly distributed in a normal distribution type. Now, when the two products are not correlated, you see there are a lot of small values and then there is some high value. And you can see that here the spread between the fifth and even the minimum and the maximum, you would see that it is larger for the second and the third case. Now the reason for that is that when you have opposite kind of demand correlation, so when one demand is kind of low, the demand for the other products would be higher. So it will compensate each other in terms of weak sales in one is compensated by higher sales in the other. So you get kind of evenly distributed total profits, not too low or too high. Okay. But in the case of totally independent, or more so in the case of both products having the same kind of correlation, so you tend to have large deviations, because if one goes up, the other also goes up, and you end up with large profit. And the opposite is if one has weak sales, the other also has weak sales, and you end up with big losses. So that's what is happening here. Big loss and then fairly good profit if both are moving in the same direction. So here is an example of multiple products having correlated demand, and how do you incorporate correlation into this demand. So we have seen several different types of modeling here in at risk. We have only scratched the surface. There's a lot more that we can do with this analysis, but even with very little that we have covered quite a lot of different ways in which you can model real life situations and really get good, very good analysis or output values that we can analyze and develop profitable and very effective decisions.